Hello and welcome to another episode of That 60s Recording Podcast, the podcast that has conversations inspired by the golden era of recording. I hope you've had a lovely week. Oh, and my name is Joe Montague and I'm your host. Bloomin' heck, I'm getting terrible at remembering this. Okay, we're nearing the end of the Ted Fletcher lectures. This one is a really good one, actually. It's about the history of media, the sort of medium of recording. It's entitled Recording Media and Early Recordings. And I found this one particularly interesting. The little caveat that I've been putting in at the beginning of episodes becomes quite prevalent on this episode because it's not completely up to date. It's fairly up to date, but there is, still talks about CDs and things like that. I mean, it's all relevant information and really interesting, but it doesn't talk about the way that doesn't come, completely up to sort of 2022, if you like. Also found it really interesting. Obviously, Ted's experience with analog recording is very different, and he's certainly part of the school of thought of things. Obviously, do need to improve all the time, which we're all there as well. But there are merits in the old sort of ways of doing things, and there is a fascination, especially with the sort of current generation, or a part of it at least, of analog recording, which is all you guys listening to this as well. I find his opinion quite interesting at that, towards the end of it, because he's obviously grown up with, his career was all about analog recording, and he could see the pitfalls in it, whereas we're actually actively searching for some of those pitfalls. So it is quite interesting. Having said all of that, I won't need to caveat it again because you've heard that caveat, and we'll just dive in with this, I think it's the penultimate episode. Here we go. Recording media and early recordings. The start of it all. The very first sound recording was made in France by an inventor called Scott in 1856. So those stories about the Edison phonograph may have sounded good and plausible, but they are actually wrong when it comes to real history. But it is true that the first sound recording medium was the wax and foil cylinder. It's strange, isn't it, how once something has been achieved or invented, how obvious it seems, particularly with the best inventions. The first cylinders were rotated directly by hand while the person recording the message shouted down a trumpet, so that a cutting stylus vibrated, making a groove in the wax. The modulation was the depth of the groove, so there was not a lot of dynamic range. Of course, the earliest recordings were almost completely erased by attempts to play them back. The cylinder, as a shape for a recording medium, was obviously not too good. It was bulky and difficult to store, and it was also quite delicate. It was a small but important step to go from recording on a cylinder to recording on a disc. The cylinder had the one advantage that the speed of the groove past the stylus remained constant at all times, once the rotation of the cylinder became motorized, but on a disc, the speed of the groove slows down towards the center of the record. However, the disc won the day because of its advantages of ease and cost of manufacture and ease of storage. Some early discs were recorded the other way round, with the start of the record being in the center and the end at the edge. In fact, this is how CDs are recorded today. In 1896, Eldridge Johnson improved the gramophone with a motor for a simple and inexpensive machine that became the most popular disc phonograph by 1900. He then merged his Consolidated Talking Machine Company with another existing company run by Emil Berliner to create the Victor Talking Machine Company in 1901, with the little Nipper dog as its trademark. Magnetic recording. The very first magnetic recorder was developed in 1898 in Denmark by an engineer called Poulsen. He made the intellectual leap from storing sound as waves on a wax cylinder to storing the information magnetically. How he did this was to run a current through a carbon microphone. Then he had an iron cord magnetizing coil in the circuit, and he passed an iron wire through the magnetizing field. Speech would modulate the magnetic field and so magnetize the wire. Some of this magnetism would remain in the wire, remanence, and the sound could be recovered using a telephone earpiece attached to a sensing coil as the wire pulled past it. The first machines had the wire wound on drums, and the movement was done by turning a handle, much the same as on the early cylinder records. In 1900, Poulsen allowed the principle to be taken up by a newly formed American company who worked on developing the machine as a telephone answering device, and by 1917 had a practical working model which was launched as the telegraphone. In the end, this really was an idea ahead of its time, and it was not a great success. The breakthrough came in the 1920s when the German Telefunken company started experimenting with steel tape. Yes, flat steel tape like thin ribbon. This was wound onto great drums about a meter across. The first practical machine was made by Kurt Stiller in Germany. Marconi Stiller Blattner phone machines, 1939. In the USA, a Dutch engineer called Ludwig Blattner experimented with steel tape as well, bought the use of the rights from Kurt Stiller, and by 1928 he had an operating tape recorder. It was a huge device with converted washing machine motors, yes, really, to drive the tape, which ran past the electromagnetic record and playback heads at a speed of 5 feet per second. Now note that speed. It was arrived at arbitrarily by Blattner as being the lowest speed at which the sound quality was acceptable. That is a speed of 60 inches per second. Years later, engineers improved tape, heads, amplifiers, and transports to such an extent that they were able to keep on halving the tape speed past the heads. Old professional tape recorders used to run at 30 inches per second. Then came 15 IPS, then 7.5, then 3 3/4, and finally the speed of the Philips compact tape cassette, which is 1/7/8 inches per second, a multiple of Blattner's original guess. But back to Blattner. He actually called his machine the Blattner phone, and there were only about 6 ever manufactured. The Marconi company continued with development of the Blattner phone, and an improved version meant that they sold about 25 machines to the BBC for radio rebroadcasting across the British Empire, but they were very troublesome and not a great success. Although, because there was nothing better, they were in regular use until 1939. The main problems with fine steel tape were the danger aspects. One was constantly in danger of being cut to ribbons by fast-moving razor-blade thick steel and the constant problems of tape breakage. The only way to repair the tape was to weld it together, and all the machines had elaborate electro-welding splicing blocks. In the 1930s and 40s, a great deal of research was done reviving the idea of recording on wire, a very much less expensive medium than steel tape. The Webcor 288, 1953. A very successful commercial recorder was introduced in the USA called the Webcor 288. Of all the mediums of magnetic recording, wire still remains at the top of the list in popularity, and the Webcor 288 wire recorder is the reason for it. The 288 is the only wire recorder with console response. Console response is the result of a new technique used in the construction and design of the sound chamber and provides lifelike, faithful sound reproduction. It is this fidelity of sound that has enabled Webster Chicago to sell more magnetic recorders than all other manufacturers combined. Beginning with the picking up of sound by the sensitive high-impedance crystal microphone and ending with the playback of any sound through the powerful amplifier and speaker, the Webcor wire recorder provides the utmost quality every step of the way. From the businessman to the hobbyist, there are thousands of uses for the Webcor 288, ranging from the recording of business conferences to the recording of animal noises. Simple enough for a child to operate. One master control sets the 288 in motion for recording and playback. Features like the elapsed time indicator, neon volume indicator, and automatic stops in both directions make the Webcor 288 the best wire recorder investment. Webcor by Webster Chicago, $167. Prices slightly higher west of the Rockies. Copyright 1953. About 100,000 of these machines were sold in the USA, and they were as popular as cassette machines were in the 1980s. Movie sound. Variable density recorded soundtrack. All through those early days, the movie makers in California were searching for ways of synchronizing sound to their films. The earliest attempts used gramophone records with all sorts of contraptions to try to maintain some sort of synchronization. They achieved it for the first time with dialogue, with the film The Jazz Singer in 1927. But the equipment for both recording and playing back these soundtracks was horribly unreliable, but there had to be a better way of marrying up the sound with the picture all on one medium, and this was of course the optical soundtrack. Variable Area System by RKO, 1935. Some early forms of soundtrack were actually mechanically recorded. The vision part of the film was edited, and a black unexposed strip was left down one side of the film. The film was then run through a special projector with an angled cutting stylus on the side, and sound and dialogue was fed to a coil around the stylus, which moved much like a loudspeaker. This removed areas of black from the film so that when it was run through a projector with a steady light source and a photocell, the mechanically cut soundtrack interrupted the light. The interruptions went to an amplifier which played back the recording. Before very long, this system was discarded in favor of a much more sophisticated galvanometer type recorder which shone reflected light via a mirror onto an unexposed film. The mirror was attached to a small lightweight coil hanging in a magnetic field. Modulation in the coil caused the mirror to rotate slightly, altering the beam of reflected light. This coil could be accurately modulated so a picture of the sound waveform could be exposed directly onto the film. There were many variations of the optical track, from the simple single-track arrangement right up to running a separate 35mm soundtrack film synchronized to the picture with up to 6 optical tracks recorded onto it. The most famous example of this, of course, is the Disney film Fantasia. The two systems, variable density and variable area, both suffered from excessive background noise due to the graininess of the film. The engineers of the time didn't realize that actually the ear is more sensitive to a wide range of signals than the eye is to light. In the RKO system, which proved to be the better of the two, the recorder designers came up with some clever noise suppression by increasing the black area during quiet passages, which shut off the light, which in turn minimized the hiss caused by the film grain. A slightly later version of the TrueVox deck, 1956. Magnetic recording onto tape started to get to a degree of sophistication in the mid-1950s. At that time, I was in the 4th form at a grammar school in Tunbridge Wells. My father, who worked for the civil service in aeronautics, was a keen amateur with electronics, and we decided to work on a project to make a magnetic tape recorder. Actually manufacturing the deck itself was a bit beyond us, so we bought a deck made by TrueVox company and used that as the basis. The amplifiers were based on circuits published in Amateur Wireless magazine, and we built the whole thing into a metal frame about the size of a washing machine. Anyway, we are supposed to be talking about recording media. The first tape, available in 1954, was actually paper-based. The iron oxide was made into a sort of paint during the manufacturing process, and it stuck very well to craft paper. Practically, it was a good medium, but the biggest advance to getting good quality on playback was the use of AC bias. AC bias. When a tiny section of a recording tape is magnetized and then demagnetized, a portion of the magnetization remains. This is the effect of hysteresis. Magnetizing the tape with audio via the record head, this effect causes severe third harmonic distortion because the waveform that is recorded is constantly being bent out of shape by this magnetic memory in the tape. At the beginning of the 1950s, engineers reasoned that if you applied a high-frequency signal over the top of the audio at a higher level than the audio itself, then there was a good chance that this would destroy this memory effect. This was true, and so magnetic recording took a huge leap forward in quality. Professional recorders rapidly appeared, with quality far superior to direct-cut discs. In the USA, the Ampex Corporation produced a range of machines which are almost universally used in studios, and they continued developing them with more and more tracks, starting with full-track quarter-inch machines, then 2-track stereo, 3-track, used mainly for the movie industry, where the 3 tracks were dialogue, music, and effects. With the use of these machines and others from Europe like Studer and Revox recorders, the quality of recordings was rivaling the quality of the microphones, preamplifiers and mixers of the day. During the 1970s, huge advances were made in all aspects of recording and reproduction, from the introduction of real quality solid-state circuitry to advances in plastics and emulsions making the tape medium close to perfect. More on disc recording. Cutting discs is exactly the same as a record player in reverse. The blank disc with no grooves in it is clamped to a powerful turntable. The cutting stylus is lowered onto the outer edge of the disc and the modulating signal makes the stylus move side to side, or in the case of stereo records, a 45-degree angle for each channel. The stylus cuts a groove in the disc, helped by a heating coil wound around the stylus. The swarf produced by the cutting action comes off the disc in the form of a single strand. This is then sucked away by a small vacuum pump. At the end of the recording of the side, the stylus scrolls inwards to a parking groove. The master disc that is cut is actually an aluminium disc with a coating of acetate on one side, very like thick black paint. These master discs are of course very delicate and generally cannot be played, or if they are, only by a very lightly loaded magnetic pickup, and only then once. To produce a commercial record from this master, it is coated with an electro-deposited layer of metal. This becomes the mother. For short runs of records, the mother can be used direct to produce discs, but more commonly, another impression is taken from the mother, and from that, several submothers or stampers are made. Early 78 RPM discs were made of a Bakelite material. It was hard-wearing and easy to produce. Its main disadvantages was that it was very brittle, and so dropping a record was not a good idea. The introduction of vinyl records running at 45 and 33 1/3 RPM improved quality enormously and also required greater precision on the disc cutting lathe. Most discs are still cut on Neumann lathes similar to the one pictured. No, obviously you're not going to see that picture. With only detail improvements over the 1960s model. Coming up to date. Digital media. The start of digital audio recording was a curious inversion of technology. For years, the Japanese electronics industry worked on the development of magnetic recording for television and came up with rival systems called Betamax and VHS. In most territories, the VHS system won the day commercially, although technically there was not a great deal in it. However, Betamax had a slightly better high-frequency resolution, and so audio engineers started to experiment with breaking sounds down into digital bits and recording it onto a video recorder. The first commercially successful digital audio recording system was introduced by Sony in 1978, called the PCM-1. This was a coding box that converted audio into a form that could be recorded on a standard Betamax video recorder. The quality was equivalent to good professional analog machines, and it had the advantage that it was a reliable system that did not rely on the alignment of a playback machine for its quality. From that moment on, most audio masters were mixed onto one of the versions of PCM-1. At about the same time, a further cross-pollination of technology happened. The computer business needed faster and more dense methods of storing data, and the floppy disk did not look much like a good long-term solution, so some developments in hard disk technology were moved sideways, and the CD happened. A brief timeline of the CD. Prototype CD system demonstrated in Europe and Japan. Sony agrees to join in collaboration. Sony and Philips compromise on the standard sampling rate of a CD to 44.1 kHz, or 44,100 samples per second. Philips accepts Sony's proposal for 16-bit audio. Reed-Solomon code adopted after Sony's suggestion. Maximum playing time decided to be slightly more than 74 minutes. Disc diameter changed to 120 mm to allow for 74 minutes of 16-bit stereo sound with a sample rate of 44.1 kHz. The choice of specs for bit density and sample rate were very much dictated by the technology of the time, and a bit of crystal ball gazing by the Philips and Sony engineers. 16-bit was an obvious choice. For high-quality reproduction, you need a dynamic range of sensibly 80 dB. And by dynamic range, I mean the difference in level between background noise and the audio signal clipping. 16-bit, if resolved with modern converters, achieves that figure. For comparison, the dynamic range of optical film is probably 60 dB at absolute best, and magnetic strip film is about 10 dB better than that. In normal professional studio practice, the best achievable dynamic range in recording studio is about 70 dB, but of course, any additional noise after that will reduce the range, so the recording medium needs to be at least 20 dB better than the range of the source material to avoid degradation. That strange figure of 44.1 for a sample rate has a little story attached to it. It was chosen because it was the highest multiple of the practical track length of one helical scan on a Betamax recorder. It was choosing to keep the digital processing simple, as all mastering in those days was done using the Sony PCM1 system, and digital rate conversion was extremely difficult. Hard drives. And so to the present day, the 21st century, when neither computer speed nor disk space is a problem. CD continues to hold its own as reasonable quality medium, while those who think that they can hear the difference, there is DVD sound with superior bit numbers and sample rates. And then there are the variations of hard disk technology in the form of minidisc and MP3, which is really only a name for a bundle of clever mathematical tricks to squeeze real-time sound through the internet with minimum bandwidth. Solid. And what may be the standard for the future, or almost certainly will be, is the use of solid memory for recording. Bostex has broken the digital recorder price barrier with their new MR8. It's the world's first 8-track that records into solid state, compact flash card memory, and there's more. It's got a USB port for WAV file data transfer to a Windows PC for data editing, CD burning, and backup. And operating the MR8 is more intuitive than many other digital recorders. It's ideal for users who have no experience in digital multi-track recording. But anyway, to get back to what is called the professional end of the recording business, there has been a resurgence of interest in analog studios and analog recording. Personally, I am cynical about discussions that try to make comparisons and draw conclusions about relative merits of analog and digital. I have to say that a recording medium should be as technically perfect as possible, with no additions or subtractions. It should be a perfect time machine that can replay what is being monitored in the control room at any time. Analog tape is not that. The best analog recorders will reproduce a result that is technically excellent over a specified dynamic range. What the books don't warn you about is the massive overload margin required to reproduce transients in the signal, and the effect that this has on the recording. Even with optimized AC biasing, which can be pulled off the tape after recording, it is limited. Recording levels up to nominally 0, the recorder will reproduce the bulk of the information perfectly, provided there are no transients. But music signal rarely has no transients. When a transient or spike comes along, the record head tries to magnetize the tape to a greater extent than it's capable of. The effect is that the signal is momentarily compressed, and this shows as second-order distortion, varying with the transient content of the music. This is not necessarily a bad thing. This is precisely the sound that complements a lot of music, and it's the very reason that engineers like using analog tape in spite of the relative inconvenience and high cost. Looking at analog in slightly greater detail, the greatest ever analog machine was probably the Studer 16-track using 2-inch tape. The 16-track has the additional track width and so is able to handle higher levels and seems to go into distortion mode in a more gentle way than the 24-track. These machines operate at speeds of 30 IPS and 15 IPS. Paradoxically, the performance of the machine is often better at a lower speed. This is to do with the gap in the record head. At the higher speed, the tape sees a smaller gap, and this adversely affects the low frequency response. Many engineers prefer to operate at 15 IPS, particularly when recording pop music. Over the last 5 years or so, It's been fashionable for professional studios recording album projects to run both digital and analog media simultaneously. For example, John Cornfield at his Sawmill studio in Cornwall installed a digital multitrack system back in 1999, but continued to record on 2-inch analog tape. I was at his studio in 2001, at which time he was proudly showing me his shed full of removable hard drives and how he was splitting the audio feeds so he could choose between digital and analog as his recording medium. But over a period of a year or so, he realised he was never using the analog tape to mix from. The reality was that the digital medium was actually better in all aspects. The operational advantages very soon meant that the 2-inch machine had become a curiosity, sitting in the corner as a conversation point, a subject of argument as to the relative merits of digital and analog. But given that the recording quality of digital hard disk is as good or better than analog tape, the additional practical advantages of digital recording make it a no-brainer, as the Americans say. In digital, we have a system that is infinitely flexible, a system that has as many tracks as anyone could want, the ability to repeat, copy, overdub, and edit non-destructively, and even to reproduce complete raw masters with no degradation. It's no wonder that the analog tape has been consigned to the specialist application. Some engineers build their business trying to use what is now rarity of the sound enhancement qualities of analog tape. I know it's fashionable to copy a mixed digital master onto 2-track analog tape machine, such as the old 3M ISO loop machine or the Ampex ATR, so that they can access the magnetic tape compression that these machines give when they are modulated up to the limit. Perhaps they're right. Perhaps it's more than a marketing Emperor's New Clothes effect, and it does have a psychoacoustic effect in the ear of the record buyer, if there are any left. But I am not so sure. Okay, there we have it. And as I said at the beginning, I think it's really interesting hearing Ted's opinion on sort of the pros and cons of analog versus digital. You know, I'm not necessarily of the school of thought that what needs to go in needs to be exactly what's in the room. I've never really thought about it like that, to be honest with you. I'm recording with a sort of means to an end, in the sense that I want the recording to sound a particular way. I kind of picture in my mind's eye what I want the recording to sound like. What I'm going for as the end result, not what I'm trying to replicate in the room. I'm not trying to replicate a live situation. I'm trying to end up with a particular sound on a record. And I think the sort of approach or the outcomes of the recording process perhaps are a little different. I'm not sure. I'm kind of thinking out loud as I'm talking about this, and it's a really interesting discussion. And I think it's a really interesting point to weigh up the whole way that kind of digital recording has brought technology really up to date, but in doing that, we've lost a lot of the creativity involved in the recording process itself. So I think there is a balance to be struck between the physicality and the necessary steps that had to happen in analog recording that facilitated some of that creativity that has now been lost in digital because of, things have become a lot easier, and we've got to restrict ourselves and put limits on ourselves in order to replicate, or in order to get that creativity back. Having said that, there's a lot of reasons involved with the sound of analog that we all seem to like as well, and whether that comes from the process going into it or the actual sort of recording medium itself, if you like, or whether it's a combination of both. I suspect it is a combination of both. But I'm finding this a really interesting topic. Strangely enough, I was approached by somebody who listens to the podcast about submitting an application for a conference, a music production conference, sort of an academic thing, submitting a talk about the podcast and the people I've interviewed and the conclusions we've come to. And it's made me think really hard over the last few weeks about what I talk about on this podcast and what it really does mean. and the not necessarily the implications, but just trying to summarize all of the thoughts and come to some form of conclusion, whether whether it's a sort of necessary conclusion or not, or just an ambiguous conclusion. But I think it's really interesting, and I think it's really cool that there's even a conversation surrounding it. So if you've got thoughts or opinions or whatever, please feel free to email me, and I'll mull it over, because I'm kind of not scratching my head, but I'm finding it quite fun to think about all of these things, and to sort of integrate the old school way and the new school way of doing things, and what implications that has for my music making and my studio sort of moving forward. Anyway, I'll stop waffling. That just leaves me to say, if you'd like to get into contact with me, you can do that through joe@allyouneedisdrums.com, and my website is allyouneedisdrums.com. You can find me on Instagram at allyouneedisdrums. I'd like to say a huge thank you to Adam Mallet for the artwork he provides, to Joe Kane for the intro and outro music, and to Rory Hancock for editing and uploading the podcast. A big thank you to you for listening, and I will be back next week. Goodbye!